Precal on March 7th. Fun stuff.
Talk to me about 1A and 2. What are we supposed to be thinking about in things like 1A? Alex?
When you've got the inside the parentheses, you're changing the period.
Okay.
So in this case, it's the period shrinks by 7.
Oh, really?
Yeah, it's because it takes.
Okay, hold on.
Well, it's not like -7x, so it's not like changing the actual graph.
What is it?
It's not -7x, it's -7 pi.
Okay.
And so it's not changing the graph, you're just plugging in -7 pi and seeing where that is on the graph.
Okay.
Oh, whoops, that's where I went wrong. My bad.
Okay, so what should we be thinking?
What is y when x is -7 pi?
Okay, how do we figure out what to do there?
Well, the period is 2 pi, so every 2 pi is going to be back where it was. So at -6 pi, it's going to be the same as it was when it was at 0.
Okay.
And then, so when it's like at -pi, it's going to be the same as it is at -7 pi, which is -1.
Okay, so what's the point of a periodic function? It repeats. Who's the it? The y's repeat. Okay, in this case, after 2 pi, or after however long the period is. Who's taking notes today? Who took notes last time?
Me.
Okay, so who comes after Emma? How's your alphabetical order, people?
Rena.
Is it me?
Okay. So we skip somebody?
No, we skipped a lot of letters now.
Oh, okay. So who talked to you about this? Is that you, Irene? No, that was Nathaniel. Who was it? Oh, Hank. Hank. Talk to me again, and I have a better picture.
So now, since you know it's like at 6 pi, it's the same as where it was at 0, and so at 7 pi, it's going to be the same as where it was at pi.
Okay, so really all I need to do is think about this part down here by the x-axis. Okay, and that's the whole point of having periodic functions. You get to slop off. How much do I get to slop off every time? Just by slop off, I mean ignore. Because it doesn't help me.
2 pi.
Okay, multiples of 2 pi, right?
Yeah.
Okay. Ladies, when you checked your video, how was it when people answered like Irene did? Could you hear?
Yeah.
Good. Darn, I hate that. Because I was also telling Irene to speak up. All right, so the cosine of 7 pi is the same thing as the cosine of pi, and the cosine of pi is big. All right. So when I get down here to things like number 2, where I'm supposed to find the sine of 1, what am I supposed to think about for that? Okay, what about the graph?
So when we do the sine graphs, we do them in terms of like pi and pi over 2, and 1 would be a little bit less than pi over 2, so you just would think about it.
Okay, so how big is pi over 2? Or what?
1.6.
Okay, like 1.57? Does that make sense? What? Because pi is a decimal at about approximately 3.14, so 1.57. So 1 is maybe there. So then what'd you say for the sine of 1? You said 0.75?
Yeah.
Did you just make that up?
That was my guess.
Okay. And what was then what was it when you typed in your calculator?
0.84.
Okay, good, good. And are we checking to make sure our calculator is in radian mode when we're doing this business?
Yeah.
Yes, okay. It would be deadly if you were in, or at least wrong, if you were in degree mode. Okay. else that we need to talk about from the homework? Going once? Going twice? What'd you say for 7A? Wait, say this again?
When x equals pi over 2.
Okay, it says find also, okay, it only says on that interval. Okay, great. Pi over 2 is the only time? You sure?
And give you 2 pi here.
Okay. What did you say when sine of x is more than 0?
0 and pi.
0 and pi. Okay, great. All right. So, did I ask you to write down the domain range period of tangent?
Yeah. Yes.
Okay, so let's talk about that then. So I think we had this graph. What else did we have to have labeled on here the other day? Where did it cross? 0,
Multiples of k pi.
pi.
Pi over 4 1.
Okay, pi over 4, 1 was an important point. And what else?
Negative pi over 4 1.
Thank you, Emma. Okay. All right, so what did you say for domain?
All the other years except x is not equal to k pi plus pi over 2.
K pi plus pi over 2. What do you think?
All the integer values of pi plus pi over 2.
So pi over 2 and then a pi later?
Yep.
Okay. All right. Anybody write it differently? Irene?
2k plus 1 over 2 times pi.
Okay. And how might we read that one?
1 half.
What kind of a number is this? Odd. So how might we read this? Odd half pies. Okay. Because this is pi over 2, this is 3 pi over 2, negative pi over 2, the next one's going to be 5 pi over 2. If we get a common denominator, these guys are equal, right? That's supposed to be a regular k pi, 2k pi. Dina, what'd you say for the range? People agree with that? Okay. What about the period? Not 2 pi? No? Why not?
Because that thing happens every pi.
Okay, we get one of these little loop-de-doos every pi, right?
Yeah.
Okay. So the period is pi, not 2 pi like our sine, cosine, secant, cosecant was. All right. So use reasoning that was similar to what we did in class the other day. Well, I have to tell you this thing first. There's one more function, okay? So what functions have we had so far for our trig functions? Sine,
Everything but cotangent. Cosine, tangent.
sine, cosine,
And
secant, cosecant, tangent.
Is it going to be 1 over tangent?
cotangent.
Okay, why do you think that, Nathaniel?
Because we've done sine 1 over sine, which is cosecant. Cosine 1 over sine, which is secant. Now we've done tangent. Are we going to do 1 over tangent?
Well, might as well, as long as we came, huh? What was the definition of tangent?
Sine over cosine.
Sine over cosine. So, cotangent, which is spelled cotangent, abbreviated COT. Uh-huh,
Wouldn't that just be cosine over sine?
okay. Yes, ma'am. Okay, so the other day, we were able to figure out what cosine over sine, what sine over cosine was by looking at the sine graph and the cosine graph and sort of thinking about what does this one do when that one does the other. So see if you can take a minute and figure out what the cotangent graph looks like. So talk to me about your plan of attack. Yeah, you got a plan of attack. Oh, Toby's got a plan of attack.
So I start with the asymptotes, which, because the sine of x is on the bottom, would be at intervals of pi.
So what now? Just in here,
Pi's.
at the pi's. Okay, so anytime that sine is 0, we're gonna have an asymptote on this cosine over sine graph. Okay? You wanna tell me one more thing that you thought about?
And at pi over 2 and 3 pi over 2, like where cosine crosses 0, it would be 0, like a point.
Okay, so when cosine is 0, that's at like pi over 2, you said, right?
And sine is 1, so then it would be 0 over 1, which is 0.
Great. And that happens at all the odd half pi's, right? Okay. Nathaniel?
If we define the function as, 1 over tangent, all those points would be hollow because you can't take 1 over.
Right, that's why I was very careful to define it this way.
Okay.
Okay. Good point. Lori?
So after I did that, I sort of like looked at the graph of sine, and then it looked like it was the the tan of x, like I don't know what to call that. It was like flipped backwards, so you have the point pi over 4 1, but then 3 pi over 4 negative.
Okay, I don't disagree with your numbers. Tell me, I missed the very first part of how you thought about this.
Well, I just looked at the points on like I graphed cosine of x over sine of x, like on the same graph,
So you graphed cosine of x and
and then
sine of x.
on the same graph, so I could look at like.
If I do that in the right place, kind of bottom out down here. Okay. Pretty lumpy right there. Okay.
So then I just thought about I just thought estimated points, and then I put like, for example, if you get really close to pi over 2, then it's like really small cosine x values, and then like 0.01 over 0.09 for the sine of x values.
Okay, so near pi over 2, the numerator, which is cosine, is near 0. And the denominator
Is near 1.
near 1.
So it's going to be really small, but still greater than 0.
Which we actually write that way.
Okay.
0 with a flying plus. Means you're close to 0, but you're a little bit more than 0. Okay? What's another good one to think about?
And then if you're on the other side of that, like a little past pi 2, it's
Over
gonna,
here?
Yeah, it's going to be like really small negative 0.01, like close to 0 but negative, over points that are close to 1. So then you still have points that are close to 0 but on like negative.
So, over here I'm near 0 but positive, and over here I'm near 0 but negative. Okay? What's another good number to think about?
Very close to pi, because when you're there, sine of x, or
Yeah, sine of x.
Yeah, sine of x is really small, but it's positive, and
Whoops. Okay?
cosine of x is near.
Oops, I got that upside down. No, this needs to go on the bottom. Okay?
And cosine of x is near 1 and negative, so you get a very large negative number flying to infinity.
So this is going to Negative infinity?
Yeah.
People agree with that? You got the reasoning? Can you move this a little bit?
Yeah.
Thanks. So near pi, the denominator is near 0, the numerator is near 1 but negative. So I have, give me an example of a number that's like, that would fit this. What would the top might be? What might the top be? And the bottom might be, okay, it's not gonna be exactly that, but you know, some numbers like that. And that result would be,
Negative a million? Almost, no. It's fine.
999, right? Okay, and it would be negative, right? So it would be way on down here,
Wow, that's very off.
okay? And then if we use similar reasoning over here, I would be near 0 and positive, near 1 and positive, flying top to positive infinity. So if I connect these pieces, I would have a deal that look like that. Is that what you drew? Tell me one other good point.
Pi over 4 and 3 pi over 4. That's where it's 1. Where it's one sine and cosine are equal,
When sine and cosine are equal, so
and when
the quotient would be 1.
and at 3 pi over 4, they're opposites.
Right.
So
The same amount above and below. So right here, 3 pi over 4 negative. Okay? And then what happens? It repeats. So on its period, tangent is an increasing function, cotangent is a decreasing function. Would you write down domain range period, please? So Jonathan, what you got for one of them?
For the domain, I said all real except that x cannot equal k pi.
All right, x not equal to k pi, k is an integer, so there we go. We agree with that? All the pi's. All right, Jack, what you got for the range?
All of this.
Okay, you want to tell me the period while you're at it?
Pi.
Okay. We're in agreement? All right, so we have 6 new toolkit functions. Sine, cosine, tangent, cotangent, secant, cosecant. All right? And guess what? What do you think happens next?
Transformation.
Transformations. Yes, we can slide those bad boys all around the plane and you do all that same stuff as Emma. I thought you would think so. So, let's have some fun.
Let's do it.
Let's graph f of x is 3 secant of 2x. Oh, God. get going, talk with your group mates about what the 3 does and what the 2 does.
There's nothing to do.
So, is.
So it's
yeah.
basically just true. Change the numbers.
Oh, whoops.
Oh, yeah.
Cosecant.
And then
Oh, thanks.
So does that mean
Yep. Okay, yeah.
so then
No. Cool.
it's a horizontal.
No, I get to keep that.
And these are at,
Still can-
Secant is one of the cosines. But doesn't the mobilize like that?
And then that's pi over 2.
but it's still okay.
There we go.
So the ask me.
That's going to negative 3. 3 and negative 3.
Once it gets there, it's gonna be at 2 pi.
You got any numbers there?
Yep. 3, negative 3, pi over 4, pi over 2, 3 pi over 4.
So put those,
Well, I messed up. That's right, here it is. I messed up and I once again confused secant and cosecant, something I've been doing forever.
Okay,
So I accidentally drew the cosecant.
Or
and what number is this?
can we change it to 1 over
This way, okay.
Pi over 2.
Or
Yeah,
like
it's
3
2,
over
it's, it
cosine
just looks like those are by monkey. Cause I don't know what it does, but I'm like kind of sick.
Can we change it to 3 over cosine 2x?
Yeah, that's living.
Does that make it harder or do you need to do that?
I don't think that would be.
I'm not sure I think it would either, but, you know, it's not, it's certainly legal.
Well, we can move wherever it's one.
This isn't very pretty.
Like there.
Yeah, you have one. Well, like,
Right.
over
so
2,
it'll
but
be
I think we have to do the 2x
case
first.
pi
Oh, yeah, yeah.
pi over 4.
Right?
Yeah, but the two X doesn't have that.
Yeah. I mean,
But the ask,
I drew
where would we,
weird
where would we want?
Right.
Is x greater
Yeah,
than
alright,
or
we can
equal
do that.
to 3
So,
and less.
You don't want
So it would be at,
would it be at 5 over 4?
Either point 0.
Cause it's 5 over 2.
Yeah, and then you have 0, 3.
right, wait,
Yeah, so now it's just 5 over 4.
Yeah. Pi over 4.
right, and your
Pi
pi turns
and
into,
then
yeah, so you're right.
Coming from that.
So pi turns into 1
pi.
Usually we answer it.
Pi over 4.
So, but do we have any?
So pi over 2 common would be 35.
So that's the first.
Wait, so it would be at like
I know we can't.
We have our
and
asymptotes and
would
then
it
we
be pi?
have those points.
So just the 3.
Right?
You have
Cause
negative
it used to be at,
That's 2 pi over 4.
it used to be at 3 pi over 4, right?
Yeah.
Okay. Oh, wait, hold on.
Okay, first of all, can you write,
Pi over 2 is not good.
can you write F in terms of T? Dana, can you do that?
Yeah, T equals 3t to 2x.
People People agree with that? Okay, what's the 2 do? Horizontal compression. And the 3? Vertical stretch. Okay. So what's going to happen here? How does that play out when you look at this picture? What y'all think of it? Emma?
It changes the period and the asymptote.
Okay. So what does the period become? The period was?
Half as much as it was, so now it's 1/2.
Okay, so the period of F is, what did you say it was?
For F?
Yeah.
It's pi.
Okay, people agree with that? Okay, and the asymptotes, let's see, the asymptotes used to be at the pi over 2s, the odd multiples of pi over 2. So down here, the asymptotes were at x equal 2k plus 1 pi over 2. Now what happens?
Now it's at 2k plus 1 pi over 4 because you horizontally compressed it by 2.
Okay, so everything happens in half the amount of time. So the asymptote, so the domain is go.
All reals except x equals 2k plus 1 over 4 times 1.
Okay. And what about the range? Rena?
X is greater than or equal to 3 and x is less than
X?
or y, sorry. I don't know why I wrote x. Y is greater than or equal to 3 and less than and equal to -3.
Well, you got me writing that. All right, is that right? Nathaniel, you don't agree?